Hello and welcome to my quick Socket I/O tutorial. My name is Miguel Greenberg, and in this tutorial I'm going to show you how to work with Socket I/O in Python and JavaScript. The focus is going to be on writing Python Socket I/O servers, but we are going to use JavaScript Socket I/O clients running in the browser as example clients to connect to those servers. And then towards the end of the tutorial, I'm also going to show you how to write Python Socket I/O clients. So this is more or less what we are going to cover. In this first part, we are going to write a very simple Socket I/O server in Python. So let's get started and install the Socket I/O package, which is called Python Socket I/O. So let's get it installed, and we are going to write a server in a file called app.py. So we begin by importing the Socket I/O package, and we create an instance of the Socket I/O server, which I'm going to call SIO. So this is going to be an instance of the server class. The Socket I/O package has two server classes. Server is this one, which works with standard Python, and there's an async server which works with async I/O. Later I'm going to show you how to create an async I/O compatible server. In this part we are going to concentrate on a standard server. So the Python Socket I/O server works with event handlers. Anytime there is something that is interesting, the server will trigger an event, and the application is supposed to create event handlers for the event that it wants to react to. So an example of an event will be when a client connects to the server or when a client disconnects. So those are two predefined events that are actually called connect and disconnect. Those are the two events that we are going to use in this part. Later we are going to use custom or application-specific events, but for now we are going to concentrate on these two very simple events. So let's write two event handlers for connect and disconnect. There are a couple of ways to define event handlers. The most convenient one is to use the event decorator. So we decorate a function with this decorator, and then the name of the function determines the event that you are handling. So this is a handler for the connect event, which, as I said, is predefined. So the name is set by the Python Socket I/O package. And then let's do another one for disconnect. There we go. So the connect event takes two arguments. The first one is called SID, or session ID. This is a very important aspect of the Socket I/O protocol. The session ID is assigned to a client when it connects. So the Socket I/O server will create this session ID, which is a random string. It contains random characters. And then whenever there is an event that pertains to this client, the SID value is going to be the first argument into the event handlers. So all the event handlers that are for events that belong to a given client will have the SID as a first argument, and this is how the application will be able to tell who is the subject of an event. The second argument is called environ. If you are familiar with the WSGI protocol for web servers and web applications, then you probably know what this is. Environ is a dictionary that has all the details from the client request. So this will allow you to see if the client sent any headers, any cookies, maybe anything as query string arguments. All those things are going to be in this dictionary. And the reason why it is passed to the connect event handler is so that you can perform authentication and authorization. So in this function, you will be able to decide if you allow the client or if you reject it. For now, we're not going to worry about any of that, but this is the place where you will do all of that. So for now, all we're going to do, we're going to accept all clients, and all we are going to do is just print that we received the client. The disconnect handler takes only one argument, which is the session ID. And here we are going to do the same thing for now. So believe it or not, this is a Socket.io server. What we are missing here is we now need to run a web server that can expose this Socket.io application. There are a number of choices. The most convenient choice by far when you write a traditional or standard Python Socket.io server is to use WSGI. So what we need to do is to take this Socket.io application and transform it into a WSGI application that we can connect with a WSGI web server. For example, Unicorn, which is one of the most popular WSGI web servers for Python. So to be able to do that, the Socket.io package has a WSGI app class that takes the Socket.io application as an argument and basically wraps it into a WSGI application. So now this app variable is a fully compliant WSGI callable application that we can connect to a WSGI web server. So now we can save this, and just to make sure that everything works, let's go ahead and install Unicorn, and let's give it a try. So Unicorn, one of the requirements of Socket.io is that it needs a multi-threaded web server in its most basic form. There are other web servers that we will see later that don't require threads, but when you don't use WebSocket specifically, which we are not yet, you need a multi-threaded web server. So we are going to say maybe 50 threads, and then we can specify what the application is. And the standard way in which this is done is with a two-component WSGI specification. So you have to the left of the colon the name of the file where the WSGI application is located, and then to the right of the colon is the name of the variable that is the WSGI application. So in this case, both are called app, and that's it. So now we are running our Socket.io web server. In this part, this is as far as we'll go. We don't have a client yet, so there isn't really much we can do until we write the client. But do not worry, that is the topic of the second part. So we will do that right away in the next part. Hello and welcome to part 2 of my quick Socket.io tutorial. In part 1, we've written a very simple Socket.io server, and what we are going to do now is write a JavaScript client to connect to it. So one of the most convenient ways to deliver a client that runs in the web browser is to serve the client files directly from the same web server that runs the application. So this is what we are going to do. So I'm going to create a public directory, and then I'm going to put all the files that are going to be served to the client in that directory. So let's start with a index.html, and here we are going to write a very standard HTML page. So head and body, and then here we can put a title, socket IO demo, and here we can write an h1 with the same name, and then we need to include the socket IO JavaScript client in this page. So here I have the socket IO documentation. This is the JavaScript documentation, the reference implementation of socket IO, not the Python one. So here I'm looking in the client installation for a CDN, and I'm going to take these are all valid options. There are a number of ways. I'm going to take the CDN.js and include it here. Script source this, and that will be the client. Now I'm noticing that this is 301. The current version is 304, so let's change to 304. I'm not sure why the documentation is out of date. So this is our client, and then we are going to have our own application in let's say index.js. So this is going to be our own client-side application. So we can save this, and before we write the JavaScript client, we can test that we can serve this page. So I'm going to open app.py, the Python server that we created in the previous part, and here I'm going to add a convenience feature. The socket IO Whiskey app class has this convenience feature that allows us to serve static files. So we can give it a dictionary that defines a mapping between URLs and static files, and then the web server will serve those files for us. And this is the most convenient way so that we can get the HTML and the JavaScript files loaded in the web browser. So this is going to be a simple mapping. The top level URL is going to map to the public directory. So basically what we're saying is that all the files that are in the public directory can be accessed as URLs that map exactly to those files. So we can save this, and we can now try this, and just for additional convenience we can add a reload statement here so that Unicorn reloads whenever the source code changes. So here if we go to localhost 8000, we now get the index.html page. So very good. So now I can split this terminal here, and here in the bottom we can edit index.js, which is going to be our JavaScript client. So we are going to create the client. Let's call it SIO, and here we just connect, and in this case we don't have to pass any arguments. We can call the IO function, which comes from the JavaScript client, and it will basically make a connection to the same server from where this file came from. So in the case where the client application comes from a different origin than the Socket IO application, then you will specify your connection URL here as an argument. And you can also pass options. There are a number of things that you can find out in the documentation. But for now, we're going to keep it simple and just make a default connection. And then on this side, on the client side, things also work as event handlers. So here we can say on connect and then pass a function. And this is going to be an event handler for the connection event, this time on the client side. And in the same way, we can do a disconnect. And now we have two event handlers for the client. So for now, we are going to keep it simple and do the same thing we did in the server. We can say connected and disconnected, and that's pretty much our client for now. So I'm going to open the inspector and the console, and now I'm going to refresh the page, and I'm going to refresh with the cache refresh because I want everything to be reloaded. You can see that in the console we got a connection, and here in the server we also got a connection, and this is the SID that was assigned to this client connection. So something that we can do now, as an example, we can stop the server, and here you can see that it triggered the disconnected event in the client. Now you will notice that the client continues to generate errors. This is a very convenient and very nice feature of the Socket IO protocol. Whenever the client loses the connection to the server, it retries. It keeps trying to reconnect. And these are these errors that you see here, that of course they fail because I'm not running the server. So the moment I restart the server, the reconnection attempt will succeed, and now we get connected once again. Likewise, we can stop the client, and that is going to trigger a disconnect event in the server. But I should warn you that, as I mentioned before, we are not using a permanent connection at this time. We're using this is called the polling transport. So a disconnection is not immediately detected. The server waits to waits for some time, and when it doesn't receive any more polling requests from the client in that period of time, then it will decide that the client disconnected. So you will see in a few more seconds, at some point, the disconnected event will be received. There you go. Hello everyone, and welcome to part 3 of my quick Socket IO tutorial. In this part, we are going to talk about WebSocket. I mentioned before that this very simple web server that we started with GUnicorn does not support WebSocket. The problem with that is that this forces the client to do this polling cycle to receive events. So just so that you understand what I mean, here we're looking at the network tab, so we're seeing all the requests that are issued by the client. So you can see that the client started issuing this repeated pair of requests. You are going to see in a few seconds that there's going to be 2 more. There you go. So this is the mechanism by which the client receives events when there's no WebSocket support in the server. So this mechanism is great because it runs pretty much anywhere. So as long as you have HTTP support on both ends, you can do this. But it's also not great because nowadays all the modern web browsers support WebSocket, and WebSocket is it's a real permanent connection. It's much more efficient to send send messages in a bidirectional way. So what we would like to do is to add WebSocket support to our server. So I'm going to show you a couple of ways to do it. So let's stop this server, and the first way that I'm going to show you is based on a different web server that's called Eventlet. So I'm going to install Eventlet. This is an asynchronous server, not to be confused with Async.io. This is a different type of async implementation. So I'm going to install it, and lucky for us, there is a JUnicorn worker for Eventlet. So we can continue to use JUnicorn, but we are going to switch to the Eventlet worker. So now we have to say -k Eventlet. This tells JUnicorn that we want the Eventlet worker. It's also a good or safe thing to limit the number of workers to 1. And this is because when you work with an asynchronous server, the handling multiple connections happens through the asynchronous support in the framework. You do not need to have multiple workers. So a single worker using Eventlet should be able to handle thousands of client connections without problems. So we're going to keep that restriction to 1. There's a way to run multiple workers. It's fairly more complex, and I am not going to talk about it in this tutorial, but it is in the Socket.io documentation, the Python Socket.io documentation, if you are interested in doing that. So next we specify the application, and I also have the reload, which we can keep. So now we are running the Eventlet web server, which supports WebSocket. So just to clear this, let's reconnect, and here we have the connected message, so everything is working. And if we look at the network, so you can see that there are a few of these weird requests, but here you can see that this transport argument is polling for all of them but 1. So eventually, after a little bit of back and forth, the server and the client agreed to use WebSocket, and this is the connection that from now on is going to be used for all the bidirectional messages that are exchanged between the client and the server. If you remember, when I closed the client in the previous example, in the previous part, it took the server a few seconds to realize that the client was gone. And this was because the client was polling. And when the client is polling, there is really no immediate way to detect the disconnection. The client basically decides that the client disconnected when it stops receiving messages. So it waits for a few seconds, and if it doesn't get any message, it calls the client disconnected. With a WebSocket connection, that is different. Since there is a physical connection between the client and the server, the moment I close this tab, then the server is going to detect the disconnection. So let me open a new tab so that I don't lose the window. And now take a look here when I disconnect. So immediately we get the disconnection. So let's bring it back. And there we are, another connection now. So this is one way. So now let's look at a second way to do this. So for this second option, we are going to use Async.io. So let's stop JUnicorn, and now we are going to use a different option provided by the Socket.io server, which is to write the server with Async.io. So what we need to do here, I'm sure most of you know that when you write an application with Async.io, you have to use a different set of keywords. There's async and await. So what we are going to do is we are going to rewrite the app.py application using async IO. So let's copy this to async app.py, and now we are going to convert this to async IO. So first thing to do is to switch to the async server class. Second thing is to change the WSGI app to ASCII app. ASCII is the standard way for web applications, web servers to communicate when using async IO. And then our handlers are now going to be async functions. One more thing that is a good idea to add is in the server we are going to set the async mode to ASCII, and this is what's going to configure the server to work in this ASCII mode inside the ASCII app wrapper. As I mentioned before, the Python socket IO package supports a number of ways, both in the traditional Python and the async IO Python. It supports a number of platforms, a number of different servers. So this async mode option allows you to specify which one you want to use. In many cases, the server auto detects what you want to use, but in this case, this is one case where we have to tell it that we want to use ASCII. So there we go. This is our new async server. So to use this server, we can work with UVcorn, which is an async IO based web server. So let's go ahead and install UVcorn with the standard option. This is going to bring a number of optimizations and also the WebSocket support. Okay, there we go. So now all we need to do is we need to run the application with UVcorn. So for UVcorn, we can say just the application specification. So in the same way as we did with GUnicorn, we include the name of the Python file, a colon, and then the name of the application instance. So actually we can also use the reload option, which we were using before, and there we go. So now we should be able to check here. We need to make sure, let's connect one more time, and let's make sure there it is. So here is the WebSocket connection, and that is it. So now we have the connected message is there, and let's try to close the tab and make sure that the disconnection also happens immediately, and there we go. So that is it. Now you have learned two ways to run a WebSocket socket IO server. So I'm going to work mostly on the first server for the rest of the tutorial. Occasionally I may also jump into this one, the async IO server, if there is anything that needs to be done differently. But for the most part, the server and async server classes are basically, they have a one-to-one mapping, and the only difference is that many of the methods, most of the methods actually, in the async server class are coroutines, so you have to await them. But other than that, the support in the server and async server classes are the same. So anything you learn in the rest of this tutorial that I show with the traditional Python approach, you can also do with the async Python approach. Hello and welcome to part 4 of my quick socket I/O tutorial. In this part, we are going to learn about the most important aspect of the socket I/O protocol, which is the ability for the client and the server to communicate. So we are going to learn how the client can send messages to the server, and likewise how the server can send messages to clients. Um, so let's begin by starting a server. Uh, so let's use the GUnicorn server for now. So let's start it with eventlet so that we get support for WebSocket. And now let's open app.py, which is our server, and then index.js, which is our client. So here we have our server and we have our client. Let's start by sending a message from the client to the server. So a really good place to send a first message, or I should say event. In Socket I/O, we call them events. So a good place to send a first event will be in the connect event handler. At this point, we know that the connection has been established, so it is a really good place to send an event to the server. So the way to send an event is with the emit function that we get on the socket object, on the SIO object. And the emit function takes two arguments. The first argument is the event name. All events have a name. So far we've seen two events, the connect event and the disconnect event, which are predefined by Socket I/O. Your application can define any number of custom events, and you can pick the names. You can use any naming conventions that you like for these names. So we have to pick a name for an event. So for this example, which is going to be very simple, I'm going to call it sum, and this is going to be an event that asks the server to sum two numbers. So the event name is going to be sum. The second argument is the data that you want the server to receive along with this event. So in most cases, the data is given as a JavaScript object, or on the Python side, it will be a dictionary. And the requirement is that whatever data that you exchange is compatible with JSON, because that's the format in which the data travels from client to server or vice versa. So let's make here an object. So say numbers, and then we can send an array with the two numbers that we want to sum. So this is a complete event that we are sending to the server. So we can save this, and then on the server side, we need to handle this event. So we do it exactly like we did with the connect and disconnect. So we create a decorated function. We call it with the name of the event. The first argument in the function is going to be the session ID of the client, and the second argument is going to be any data that the client sent with the event. So we call this data, and for the first test, let's just print SID and data. So this should reload the server, and it did. So now if we connect, we so we have the connected message, and then when the client received the connect event, it sent a new event on the same SID as before, and here is the data that we received, which we get as a dictionary in the Python side. So let's go ahead and implement this. So we can say result equals data numbers 0 plus data numbers 1. And for this first solution, we can now send an event back. So the server will now send an event to the client indicating what the result of the sum is. So it's actually fairly similar. The function is called the same. It's called emit. We need to pick an event name. So for this one, we can use some result, let's say. And here we pass the data as a dictionary. So result and then the value. Now, when you emit from the client to the server, you always clear on who's the recipient. From the client, there's only ever one possible recipient, which is the server. When you emit from the server maintains multiple connections with multiple clients. So you have to specify to which client you want to address an event. So, and you do that using the to argument. And to identify the recipient of the event, you use their SID number, which conveniently we have received as an argument on the incoming event. So now we're saying that we want to send this to the same client that sent us the numbers. So now we have the client sending the numbers, and now we are replying back to the client with the result. So now we need to go once again to the client. We need to implement this sum result event in the client. So here we do it like this. And here we can once again use the safe approach of logging what we receive. So let's open the console here and refresh without the cache. And here you can see that we have received the result. So this is the basics of, as I said, the most important feature. This is how the client and the server communicate. So because there are some minor differences when you work with async IO, what I'm going to do now is I'm going to show you how to update the async IO server to work in the same way as this one. So we can actually copy this event and then open async app and paste it here. Oops, not there. There we go. And here this is going to be an async function, and when we call emit, we are going to use await because the emit function in the async server is a coroutine. So that's it. So this is the implementation for the async server. So we can save this, and now we can stop gunicorn and restart uvicorn instead, and make sure that, well, we already have it right there. Let's do another run, and once again we get the correct results. So this is the basics of how clients and server communicate. There are a few more variants and convenience features that we are going to see in subsequent parts of the series, but the basics you already have. The emit function is the way that the client and the server use to communicate. Hello, this is part 5 of my quick socket IO tutorial. In this part, we are going to talk about callbacks. So in the previous part, I showed you how to send a message or an event from the client to the server, and then we've seen how the server can respond by sending another event to the client. So this is a very common pattern where the client sends an event to the server, and then it expects a response. Or sometimes we haven't seen this, but we are going to see that sometimes the server may send an event to the client and likewise expect a response from the client. So this is a very common pattern. So in Socket.io, there is a way for an event to generate a response without the need for the other side to send a different event like we did in the previous part. So in this part, we are going to see how that works, how we can change that some event to generate a response without using that second event some result. So let's start the server once again, and let's open our client and our server. So here we are. So we have the client which sent the event to the server. So in the server, we are going to change this, and instead of sending the result as a separate event, we are going to send it as a response. And in the Python side, this is implemented directly by returning the value from the handler function. So we are going to remove that and just return the result. So on the client side, to receive this result, we need the client to request it. So the way that works is in the emit function, as a third optional argument, we can add a callback function. So if the emit has a function as a third argument, then the client will ask the server to send a response, and then the Python server will collect the response from the returned value of the handler function, and then we are going to receive that here as an argument. So we can go ahead here and log the result. And now we are not going to be using this some result event anymore. So let's save this. The worker restarted. So let's connect and open the console. So you can see here that we are logging the number 3. Note that in this occasion we just returned the number. So here in the Python side we returned the number. So that's exactly what we received. If we were to return this as a dictionary, then now we can okay, sometimes it takes a couple of seconds for GUnicorn to reload for some reason. Let's wait until it reloads. Okay, and now you can see that the result is exactly what we return from the function. So now you know how the client can request a response for an event that it sends to the server. This feature also works in the reverse direction. So when the server sends an event to the client and expects a response, it can also be provided. So for that, let's add a second exchange that is initiated by the server. So this is going to be a little bit more complex than before. So in the connect event, what we are going to do is And this is going to be a good example of the server sending an event to a client out of the blue. So basically without the client sending an event first. So here what we are going to say is start background task, and let's call it task, and pass it as an argument. So basically what we're doing here is telling the server to start a background task that will run in parallel with everything else, and this task will receive the session ID from the client as an argument. And here what we are going to do is we are going to wait 5 seconds, and then out of the blue we are going to send an event to the client. So continuing with the arithmetic theme, now we can request a multiplication, and here we can pass numbers 3 and 4, let's say. This is only going to start the thread and then return immediately, so the connection event will run and finish, and then this task will run independently, wait 5 seconds, and then initiate an event to the client. So the event is molt. So now we go to the client and implement molt, and we receive the data, and here we can start by printing the data just to make sure that we have it, and this is still taking time to reload. There we go. So now we need to wait 5 seconds, and in 5 seconds we should have the event. Or actually I need to reload this because I did not refresh the client. So reload without the cache, and now we need to wait 5 seconds, and here is our event. So we have numbers, which is an array of 2 elements. So here we can create a result, which is going to be data.numbers 0, data.numbers 1, and to send this result back to the client we have to use a callback function. So this is as you probably know, in JavaScript, callbacks are very important. A lot of things are done with callbacks. So in this case you have a second argument into your handler function, that is the callback function. So now we can invoke the callback with the result, and this is how we pass that response back to the other side. So in the server we have this emit, and here we can in the simpler option we can also add a callback, which is going to be a separate function, and this function is going to receive the result. So here we can print the result. So let's try this first, and then let's see if we can improve this and make it a little bit more Pythonic, because this is honestly this is kind of ugly. So let's give it a try, make sure that it works, and then continue with some improvements. Okay, so let's refresh and wait the 5 seconds. Oh, of course, 7. Should have done multiplication here. Yep. So let's fix that. And try one more time. make sure that we receive the correct result. Okay, there we go. So now we have the result. So this is fairly normal for JavaScript, but in Python, using callback functions is extremely awkward and rare. You normally don't see this type of pattern in Python code. So the Socket.io server for Python provides a better option. So we can remove the callback, and then instead of using the emit function, we can use call, which basically takes the emit function and the callback, combines all of that into a single function call, and makes it look like a normal call, as if you're calling a function. So then we will be getting the result as the return value from the call function. And here we can print the result. So now we can eliminate that ugly callback. So let's give it another try and make sure that everything works. Okay, let's refresh. Oh, cannot use call to broadcast, of course. I forgot that this needs to go to the correct user. Okay, let's give it a try. Let's wait 5 seconds. And there we go. Then we have our 12, and we don't have to worry about those callbacks anymore. So remember that this call way of sending an event and receiving the response is particular to the Python Socket.io server implementation. In the client, if you want to avoid callbacks, then JavaScript provides a number of ways to do that based on promises. So you have some options as well that I'm not going to discuss in this tutorial, but there's definitely ways to improve this on the JavaScript side. This is part 6 of my quick Socket.io tutorial. In this part, we are going to talk about broadcasts. This is a feature of the server that allows the application to send an event to all the connected users with a single call. So to demonstrate how broadcasts work, what I'm going to do is to add an event that is sent to every client that contains the number of connected clients. So anytime a client connects or disconnects, we are going to send an updated connection or connected client count to all the clients that are still connected to the server. So we are going to start by keeping track of the connected client counts, and we do that by updating a global variable in the connect and disconnect event handlers. So in the connect handler, we increment the variable, and then in the disconnect handler, we decrement it. So now we have an updated count every time a client connects or disconnects. So what we can do here directly in the connect and disconnect event handlers is to send the event to everyone. So we use the same emit function. We can call this event, say, client count. The data could be, let's make it just the number. So this is going to be a number that's going to be received by the clients as the argument. And then if you recall, in all emit calls that we've done so far, we then used a true argument to specify who was the intended recipient of the event. So when we want to do a broadcast, we we don't include the to argument, and then the framework knows that the event is addressed to every connected client, so it'll deliver the event to every client. So this is it. We can add another one here in the disconnect, so that we keep both updated, and we update every client when the connected client count changes. So then we can go to the client, and here we can handle the client count event. The handler will receive the count as an argument, and this is going to be a number, as I showed you before. And here we can say console log there are count connected clients. So let's do it like that. Very simple. So let's connect a first client and look at the console, and the console has there is one connected client. So let's add a second one in a separate tab, and this one now shows that there are two connected clients. But if we go back to the first, you can see that this first client also received an event when the second client connected. Let's add one more just for fun, and this received a 3 count, and then the client number 2 also received the 3, and client number 1 also received the 3. So now let's take client number 2 and kill it, and now the 3 count went down to 2, and this one as well. So you can see that this is pretty straightforward, and this is the way to send an event to every connected client. So in the next part, we are going to see a variant of this that allows the application to address a group of clients, but not all clients. So we're going to see that in the next part. So we'll see you then. This is part 7 of my Quick Socket I/O tutorial. In this part, we are going to talk about rooms. Rooms is a feature of the Socket I/O server that allows the application to create groups of connected clients, and then using the emit function to send an event to the group. So all the members of the group will receive the event. So to demonstrate how that works, I'm going to implement something somewhat similar to what we did with broadcasts. So with the broadcast feature, we were broadcasting the number of connected clients to all the clients. So what we are going to do now is, when a client connects, we are going to assign randomly a group to it. So we are going to put the client either in room A or in room B. And then whenever the count of clients in a room changes, we are going to broadcast the number, the updated number, only to that room. So let's add counts for our 2 rooms, and then here we can randomly assign clients to rooms. So I'm going to import the random package from Python, and then here in the connect handler, I'm going to randomly assign a client to a room. So if the random value is above 0.5, we are going to put the client in room A. So we do that with the enter room function, and this function takes the SID of the client as first argument and the name of the room as a second argument. And the name of the room is completely application specific. We can use any names here. So I'm going to call this one A and the other one B. So there we go. Now we have clients going randomly to a room. So we can use this conditional to update our counts as well. And right here we can send an updated count to the room. So we use once again the emit function. We can call this event room count. The count is going to be the one for the A room, and to specify that we want to send this event only to the participants that are in the A room, we use the same to argument, but instead of providing the SID of a specific user, we give it the room name. So now we are sending this event to all the clients that are in the A room. And then likewise, we do the same here for room B. And we send the B count in this case. So we still have to implement the disconnect. Let's leave that for a second phase. Let's go ahead and implement the client first. So public index.js, and now we need to do a room count event, receives the count, and here we can again log there are count clients in my room, let's say. So let's see how that looks. So let's connect one client, and there is one total clients and one client in my room. So far so good. Let's see what this second client gets. So this client apparently went to the same room as the first. So if we now look at the first client, it also received the 2 updates. So let's try one more. And let's see. Once again, this all 3 apparently are in the same room. Let's make sure that the updates were sent. Okay, let's keep going. Eventually we should get one that goes to a different room. Okay, there we go, finally. So now we have 4 connected clients and we have 1 client in this second room. And if we look at the previous 3, they did receive the broadcast with the total number of clients, but they did not receive the room count event because that went to the other room. Let's do just one more. Oops. Let's see what we get here. And this one went also to the second room. So this one has 2 clients in the room, total of 5. This one the same. And these 3 receive the 5 update, but not the room update. So this is looking great. And we are not ready to try the disconnections yet. So we have to implement that. So let's go ahead and do it. In the disconnect event, now we need to figure out in which room this client is, and then update the count accordingly. So we have a there's a SIO.rooms function that takes the user SID, and this returns all the rooms the client is connected to. So we can say if A in the rooms of this client, then A count needs to be decremented, and else we can assume that it is in the other room, so B count will have to be decremented. So then we can bring the two globals from the connect handler, and then we can also copy the emit. So here, when we update the counts, we can also send the event to the correct room. And there we go. So this should be it for the disconnection. Let's fix this lint error, and perfect. So okay, so this is going to take a moment to reload, and then we can start again. Okay, so so this one reconnected, and we have 1 and 1. Let's open a second one and see where it goes. So this one went to the other room, so now we have a 1 in each room. Let's open a third one. This one now went to the room with the second client, and the first client is still with one client in the room. So these two are in the same room. So if I remove one, then it receives the two connected clients, and now one client in the room. This is the only one, and this one just received the two connected clients. So this is working great. So so this is rooms. One thing that I should mention, in this example, I created a partition of clients, so a client can be either in room A or in room B. This is not really required. The way you assign clients to rooms, it's really free form. A client can be in multiple rooms at the same time. A client can be in no rooms. Different clients can be in different rooms, and there's really no pattern. So the number of rooms a client can be in is unlimited, and you can basically create any groups or subsets of clients as your application needs. So this is it for rooms. Hello and welcome to part 9 of my quick Socket.io tutorial. In this part, we are going to talk about user sessions. A user session is often useful as a way to store information that is specific to each client. So you will be able to store data, and then anytime you get an event from the client, you can recover that data. So Python Socket.io will keep track of this information for each of the connected clients. So what we are going to do now to demonstrate this is this username that now the server is receiving from the client. We are going to write it to the user session so that we can remember this username later when other events from a given client occur. So here in the connection handler, once we are past the authentication check and we know that we have a username, we are going to write this username to the user session for this client. So for this, we use a context manager. So we open the user session for the user for the client given by the SID value that we received, and here session is a dictionary, so we can write any key value pairs that we'd like to be remembered for this client. So we can say session username is equal to username, and this is how we store this username in the session. So what we can do also, just to see that everything is working, we can emit a broadcast. We can do a broadcast letting every connected client know that this user has connected. So we can say user joined, and we can pass here the username as an argument. And we don't pass any value for the to argument because this is going to go to everyone. So this is a broadcast. So then we can do the corresponding thing when the user is disconnected. So here in the disconnect handler, after we do all our previous things, we can say once again from the session, we can say user left, and we do another broadcast. We let everyone know that now the user has left the system. And here we have session username, which, as I mentioned before, we set it in the connect handler, but anytime we open the user session for this SID, we can access this information. And of course we keep a different set, a different dictionary per client connection, so they never mix up. So there we go. So now in the client we need to add the user joined and user left events. So let's open the client and let's add a couple more events. User joined, the argument is the username, and here we say user has joined, and then another similar one for user left. Oops. And we can say has left. There we go. And let's see how this works. So now I'm going to log in as Miguel, and you can see here that I have received my own broadcast. So let's do another one. Let's use Alice. So here we have user Alice has joined, and this one has also received the Alice broadcast. Let's do one more with Bob. And here is Bob, and here is Bob as well. So now if Alice goes away, we have, you can see that the name was remembered. So now we can do things by username instead of by the SID, which sometimes is not really that representative of a user. Hello and welcome to part 10 of my quick socket IO tutorial. This is the last part, and here we are going to discuss how to build Python socket IO clients. Throughout this tutorial, we built a Python socket IO server, and we connected to it with a JavaScript socket IO client. So I'm going to show you an equivalent client to the one we've been using with JavaScript, but written in Python. So before I begin, I should note that if you are going to work with Python socket IO clients, there's an additional dependency that you need to install. So if you are going to use the standard Python client, and by that I mean not the async IO one, the standard Python. You have to install Python socket IO with a client extra option. This brings additional dependencies that are needed only for the client. If instead you are going to work with the async IO client, then you have to add the async IO client extra to the install. So either way, you will have this needed dependencies so that you can write your clients. So let's open the standard Python client first. Take a quick look. So you will see that there's more or less a one-to-one correspondence between how we write a server and how we write a client. There are some minor differences, but overall it's more or less the same. So instead of a socket.io.server, now we create a socket.io.client. For the events, we use the same syntax. The connect event, actually the disconnect as well, they don't get any arguments in the client, but other than that, they work the same. You can see that for the sum event that used the callback. In JavaScript, we used a callback function, but now in Python, we have access to the call option. We combines the emit with the callback all in a single call, and it returns the result from the callback as a result from the call function. So we can take advantage of that when we use Python. Connect error works in the same way as in JavaScript. So we receive an error object that we can print. In this case, it is a dictionary. And then we have the multiplication event, which takes the data, same as in JavaScript. Really no difference. Client count, room count, they all work the same. Here's user joined and user left, which indicate the users that joined and left the server. And then here at the bottom we have a main function that makes the connection. So in JavaScript we used the IO function to make a connection, and we didn't specify a URL because the browser has a concept of a current URL, and that's what it used. So here when we connect, we use sio.connect, and we pass the URL of the server. We have to indicate the host name and the port and the scheme, and then if you recall, we were passing the username as an extra header. In the Python client, this is easier. You just pass a headers dictionary with all the extra headers that you want. In this case, I'm taking the username. This comes as an argument into the main function. And here at the bottom, I'm taking the first argument from the command line, if it's available, and if not, I set it to none. And this is how we are going to test a rejected connection. So after we make the connection, I call this wait function. And this is the way the client works, because everything is event driven. There is really nothing else to do other than waiting for events. So this sio.wait function will wait until the connection ends, and it'll return at that point, and then the application will exit. So this is the traditional Python client, and the async IO client is actually similar, with the exception that some of the functions that they emit and call are awaitables, so you have to use the await option. So are the connect and wait. So these are coroutines, so they need to be awaited, and for that reason I made the main function also a coroutine. So let's give it a try. So we have the server running, so now we can run client.py with our arguments. This is going to be rejected. So now we can pass an argument to get logged in, and you can see that we are printing the same things. We're getting all the same results, both in the server and in the client. So now I have this client connected. I can go to the browser and connect the second one, and you can see that the Python client gets all the notifications as well. So let's add one more. And there we go. So this is the client. So you can see in the description the link to the code if you want to inspect the code, which by the way is available for all the parts. So you can inspect the code and play with it and make it yours. So I hope this tutorial was very useful to you, and I hope you learned something new and you start building more Socket.io applications. Thank you and good luck. Hello and welcome to part 8 of my quick Socket.io tutorial. The topic of this part is authentication. What I'm going to do is build a very simple authentication system for the Socket.io application that we've been building throughout this tutorial. So let's start from the server. As I mentioned before, the connect event handler receives this environ dictionary as an argument. This dictionary is formatted according to the WSGI specification, and it contains all the details from the client connection request. So that means that we have access to cookies, to any basic authentication arguments, custom headers, standard headers. All of that is in this dictionary. So from the information in this dictionary, in most cases you should be able to authenticate your user. Now, the way you authenticate will largely depend on your own application. On a real world application, there's going to be a user database, and you will be able to check maybe passwords or API tokens. Because I have none of that on this simple application, my authentication logic is going to be simplified. So what I'm going to do is I'm going to require the clients to pass a username in a custom header, and when the username is given, I'm going to allow the connection, and then for clients that do not pass a username, I'm going to assume that they are unauthorized, and then I'll reject those connections. So let's see here how we can get the username out of a custom header. So this is going to be on the dictionary, and then for custom headers, the WSGI protocol prepends all the headers with the HTTP prefix, and then you have the name of the header in all uppercase letters and with dashes converted to underscores. So I'm going to use a x-username header name. So in this case, it's going to be x_username, and it's going to be all caps. So this is my username, and then if the username is not set, then I need to stop this connection. And the easiest way to do that is to return false from the connection handler. So on this connect event handler, the Python Socket.io framework checks the return value, and if it's false, it stops the connection. It does not let the client in. So really, this is it. There's another way to reject a connection, which involves raising an exception. You're welcome to check the documentation for Python Socket.io if you're interested in that. The benefit that that option has over this one is that you can provide a customized error message that goes out to the client. But we'll keep it simple here and just return false. So there we go. This is our client. So now when we connect from this is our server. I'm sorry. When we connect from the client, the connection will be rejected until we add that username. So let's open the client, and before we implement the username, we can see how the connection error is handled. So there is a connect error event handler that is invoked when the connection is rejected by the server. It receives an error object, and here we can do, for example, let's log the error just to see what it looks like. So that is it. So now let's connect and see what we get. So there you go. This is an error object. It has a message, and it also shows a stack trace. This is a stack trace for the client side. If you are not interested in the stack trace, then what we can do is we can just log the message attribute, and then now we only log the error message. And as I said, this is a predefined message from the server that is used when you return false. If you raise an exception, the connection rejected error exception, you can provide your own custom message if you'd like. So what we need to do now is we need here in the connection, we need to add that custom header that has the username. So the way to do that is a little bit convoluted. There is transport options. So this dictionary argument or object argument that I'm passing is used to pass configuration options to the client. So transport options, polling, and here we can provide extra headers. And this is where you can put your custom headers. So here we are going to say X username, and here we will have the username. For now, let's say we hard code it just to see how things look like. So something important that I should mention, you can see that the extra headers option is under polling. You've seen before at the beginning of the tutorial that there are two transports. The polling mode, which is the default, which we've seen in part 1, and then the WebSocket transport, which is more efficient, and we've seen later, I believe, was part 3. So when you connect through WebSocket, there's no way to send custom headers. For some reason, the WebSocket specification does not include the ability to send custom headers. So these can only be sent when you do a polling connection. So because of the way the Socket.io protocol works, a polling connection is established first, and then only then a WebSocket connection is established, and then it takes over the polling connection. So this works fine. There's a mode in Socket.io where you can connect directly with WebSocket. If you do that, you will not be able to send custom headers. So keep that in mind. It's for that reason, it's usually a good idea to let the protocol work in the default way, which is to start with polling and then upgrade to WebSocket. So this is it. Actually, now that I think about it, in the server, we should also log what we're getting so that we can check that everything is okay. So let's add a print there with the username. So So the client is ready. So now let's connect again, and we got connected, and here you can see that the username was received by the server. What's left to do here is to replace this hard-coded username with one that we provide. So to keep things simple, I'm not gonna waste time implementing a login form or any of that. I'm gonna take a shortcut here so that I can provide a username very easily in the URL. So what I'm going to do is I'm going to use the fragment portion of the URL to pass a username, and this is how I'm going to get it here. So when you write a URL like this, you can do from JavaScript location hash, and this is it's actually, to make it more complete, it will be window location hash, and this is how you get the fragment portion. If we do substring starting from 1, we eliminate the hash character, and this is the username. So I'm going to use this here as my username. So now if I want to log in with Miguel, that's how I do it. So there we go. This is the simplest user authentication system I could think of to show you how this works.